So, hi, Andy. Welcome back to the show. You had some discussion topics you would like to discuss with me about Java EE testing, and you had a survey going on. So, why you are so interested in testing right now?
Hey, Adam. Thanks for having me back. So I was looking at the way that we test Java EE and MicroProfile applications, and I've been looking at some of the ways that other frameworks out there do testing and provide a testing experience to their users. And I was basically just noticing a gap there, some room for improvement. So I just kind of wanted to put out a survey and get some feelers out for what people are having trouble testing with, where we think the testing experience can be improved, and if there's like certain areas of testing that we want to focus on. Because I know a lot of people, if testing is too hard, it makes, the consequence of that can, in some cases, be in a worst case scenario that our users just don't have tests at all. And that ends up with, that's not a good situation to end up in.
Yeah. So I always filled out your survey, but then stopped. The reason was I wondered myself, what kind of testing you are asking for. And there were questions like, what's about the performance of tests? And from my background, so testing is a huge in enterprise companies in Europe, and they are interested in, also the companies are interested in statistics, code coverage, and developers are interested in providing the stats, and some reasonable projects are just, interested in good software, but
Yep.
and why I was a little bit confused because, as you probably know, so larger projects, they such a project comprises people from different companies, and they're working together. And what's most important thing is to define the terms. So what I usually do is to pick some common definitions, usually Wikipedia, because it's accessible and you don't have to read a book, to understand the definition. And what I found is basically you have unit tests, integration tests, stress tests, and system tests. These are the different tests I know. And we can walk through all the tests, and I can tell you what I'm doing in projects and where the confusion usually is. And there is lots of confusion. And then, you can ask me a question, whatever you like. So sounds good?
Yeah, that sounds great. So I guess just off the bat, I'll address your confusion with the type of testing. And really, I was just, I'm looking at testing as a whole, right? So when we take a step back from testing, I think the reason why we write tests ultimately boils down to developer confidence. It doesn't matter how many test cases you have, how long they run for, what % of code coverage you have. I think the primary reason why we should write tests is so that developers can have confidence that if they make a code change or if they change something in the system, then they can, kind of sleep well at night knowing that their changes aren't going to suddenly break in production or they're not causing a functional regression. So the main thing that I'm looking at now is, with the survey especially, is just ways to improve that confidence and where that confidence is lacking. So it could be anything. It could be unit tests, integration tests, and system tests.
Yeah, you're right about the confidence, but it is it's really hard to be completely confident whether it works or not. I'm actually using the test also, of course, for regressions, for future regressions, because actually, if you're working on software right now, I'm pretty confident, or you are pretty confident that the software is working. The problem is only if don't work at this project several months or years, they come back, then you are no more that confident. So having a test is a great vehicle to reassure you or rekindle your confidence, right?
Yes, absolutely.
Yeah,
and I think
and the productivity for me is a huge one. To give you an example, right now I'm working on a tool which I will probably release as an open source, and this tool will just create in an easy way JSON Web Tokens, And in order to have a JSON Web Token, you will have to have public and private keys generated. And so prior unit tests and unit testing, what I would do is, let's say in the year 1996, I would write lots of main methods, which will just invoke pieces of or slices of the software, just to to see some subsystems working. And right now, I wrote 3 classes, and I will just write unit tests in order to see whether the public and private keys are generated into the right folder, whether the folder meets my expectations. Otherwise, so for me, it is faster to write a unit test and see what happens than think longer about how the passage should be and what the idea behind.
Yeah, definitely. There's certainly a time and a place for unit tests, for sure.
And so in my let's say commercial projects, the unit tests, integration tests are less important, and the most important tests are so-called system tests, and they are mostly ignored in projects because these tests do not generate usually any stats. So the code coverage could be gathered, but usually it isn't. So most projects ignore this test, which is almost criminal in microservice environments. But so what these tests are is, imagine you have a resource which with several let's say get, post, and put, delete methods, and it exposes JSON. So you would write another module, and this module will comprise a JAX-RS 2x client or MicroProfile client, and will call from outside the service. So it is replacement of Postman or curl, and we are using this to speed up productivity, but you get real regression, and you can measure the backward compatibility of microservice API or REST APIs. So this is the most important part or category of tests, which are usually start with in microservice environments. So this is what I will do. And in order to run this test, so how this usually work is locally, you have a local server running, and your system test will access the server locally. And let's say in a cloud-like environment, Kubernetes or OpenShift, we have a Jenkins pipeline, which will deploy the microservice in a production-like environment, verify whether it is up, and then run the tests against the microservice.
Yeah, that sounds definitely, I think, for starting off a project, just having that one system test is super important, just to make sure that everything works as in the most bare bones sense. And then as you continue to add new features, just build incrementally on it.
Yeah. And this is almost like test driven, because you are forced to consider your own API from outside. So you are not, you are writing the test almost. You start with the unit test, and then you're writing the resource, and then you also can, you have to think twice how your REST API looks like. So you are forced to increase the quality. So you are your own user of your own API.
Yeah, I'm a big fan of test-driven development. That's one thing that we practice a lot internally at WebSphere for testing out OpenLiberty, the runtime itself. And it's just, I'm a big fan of it because we don't have the problem of a bunch of test debt. So if you can be writing tests for your code and delivering them in parallel, it doesn't, in my opinion, it doesn't really matter if the developer writes the test or the product code first, but just so that they're delivered together, so you're not delivering untested product code.
Exactly. So
I think that's super important.
The whole discussion whether the test is first, last, or in between, I really don't care. So don't be dogmatic, but to have good coverage for the system test is crucial. And
yeah, definitely.
With that, a small hack, what we do, we run the application server in a code coverage mode. This is the first hack. And what OpenLiberty could do, for instance, is to provide an easy configuration, just ship with Jakarta or something. So it could run in Jakarta mode. I mean, it's not a big deal. Usually you just set up the Jakarta agent in, and start the server. But the cool story is if you have your system tests, they are executed against the REST API, your code coverage is supposed to be pretty high because you went through the happy path through your applications. I would say you could achieve out of the box 60, 70, or even 80% of code coverage. And the question is, what about the 20% of remaining untested path? And usually what happens is forgotten code. So what we do is we delete or we use code coverage with system tests to identify that code.
Yeah, and I think if you're, I think code coverage is great for determining that you're covering all the error paths properly, because I agree, like, yeah, if you just do one system test, you're probably going to hit 70 to 80% of your code path, depending on how much error handling code you have. But that last 10 to 20% can be pretty tricky to cover in a system test environment. But even so, I think it's still doable. Like for what my team does in IBM is we still write integration or system level tests even for our error path scenarios to make sure that works properly. And then instead of what we do there is, since sometimes they do take a bit longer to run, is we categorize them into basically two different running modes, like a fast and a longer test running mode. So the fast test run mode runs with every change. That's what people run by default. And then we have the more longer running test mode that executes kind of like on a once every 3 days basis. But those tests are still just as important. If they do fail, they're just as important as any of the other tests.
Mm-hmm. So in projects, it's a little bit different. So the system tests are crucial, but they run last. And before the system tests, we have unit and integration tests. And the unit integration tests, they are almost just for productivity reasons. So almost, it really depends on the project. So most of the projects are better database browsers, not like, we are writing hugely complicated enterprise systems. Usually we just, accessing external systems, fetching some data and exposing the data via REST. And in this particular cases, we don't have a lot of complex code. And so what it means is we are only writing unit tests for non-trivial methods. So actually for getters and setters, it is forbidden to write unit tests. And so therefore, we don't have a very high unit test coverage. For instance, we wouldn't test JSON-B data transfer objects, for instance. It doesn't make any sense. And so code coverage unit test is pretty low in my projects because only complex code is tested. And integration tests, what we do then is we launch, for instance, the entity manager in the unit tests with, let's say, Eclipse Link or Hibernate behind the scenes with a dedicated persistence XML. So we boot the Eclipse Link just to test, the persistence, name queries, and so forth. Or in project where we have just the bean validation, so we just launch the bean validation without the server. And only in rare cases, we test the CDI dependency injection, and the reason for that is we usually don't have a lot of qualifiers, alternatives, and specializers in business code. So usually we have just plain at inject without any interfaces. This is like 80% or even 90% of microservice code. So testing whether the dependency injection works or not is pointless. So therefore, in business projects, we actually never use Archillion.
Yep. So, yeah, that's an interesting point you touched on there with the mocking up the the entity manager or the bean validation or whatever.
Not even mocking out. So what you do, so you would start, let's say, a class which has injected entity manager, and you would create your own entity manager with persistence create entity manager factory dot create entity manager. So you get one, and it will just set it. So you get a real one, not a mocked out one, but probably with different database or something like that.
Yeah, and I guess you're right. It is a real entity manager. It's not being mocked out. I was thinking about it more in the sense that it's not true to the exact code that will be running on when you deploy your application to, say, an application server. there can be very minor differences there, such as if you have different things on your class path, or if you're using, version 1.2.3 of a library, but the application server is using version 1.2.4, and there might be, a slight bug fix or behavior difference in that situation.
You are right. So what do you usually...
So there's a very small risk there, but yeah.
Yeah, but you're right. So what you have to do is really you have to look into your application manager, which exact version of Eclipse Link Hibernate or whatever is used, and I try to use the same. What already happened was we used a newer version of Eclipse Link, and back then Glassfish had an older one, and we didn't have that problem during integration tests, but the application server had that problem. And so since then, 10 years ago or 5 years ago, we looking exactly at the version which is used. But you're right. Yep. There's some additional, I would say, effort going on at the beginning of the project. Yes.
Yeah, and just to I guess touch on that topic a little bit more. In getting back to the survey I put out, I asked, one of the questions there was, if you don't have maximum 10 out of 10 confidence in your automated tests, what factors are causing that lack of confidence? And by far, the number one response, that was the number one factor that was impeding developer confidence in their tests, was the tests we have do not accurately represent how our application behaves in production. Mm-hmm. So that's one of the things that I'm trying to look at currently, seeing how we can close those gaps. So like what you're doing, trying to see what version of what library the application server is using, that's a great step. But I'm still concerned about that small gap in behavior difference that could be there, and kind of looking at ways to close that gap.
Absolutely. I would say so far we would be pretty confident that it will work. So I would say it would work. The next problem you get is stress tests, and they are also completely ignored. So what usually happens is the system tests are reused. So we are just, as what I'm doing, I'm just taking the JAX-RS client. So this is one of the reasons why I never used libraries like, for instance, REST Assured for system tests, because they cannot be as easily reused. So my JAX-RS system test is just taken. I just delete all the asserts and package that, for instance, with JMH, Java Micro Benchmark harness. Yep. And then they're producing a massive load. So I'm bombarding the application server with requests. And then we are fetching via REST, via the MicroProfile matrix. We are fetching the matrix, and we try to find out whether the threshold is actually met. And with that, at least, you will see whether your application server is properly configured. So, the thread pools and so forth. And usually, if your application breaks, it's because most of the application servers go into production with default settings, and no one has an idea how it really behaves. There's no thread pools configured, no timeouts configured, nothing. And I would say 20% of my work is to find such problems.
Okay. Yes, I think you're right. Stress tests do get ignored a lot, and I think it's really difficult to do proper stress testing, because to do a proper stress test environment, you really kind of need to have a pristine, dedicated machine to run performance, or at least a machine that's not busy doing a bunch of other work. For example, if you have your app and you plug it into a Travis CI/CD pipeline, you're probably not getting, and that can be a free pipeline for a lot of projects. You're probably not getting the best hardware. It probably doesn't have the best performance or even reliable performance. So in those situations, I think it's really hard to have developers write stress tests, because there's no clear and consistent platform that they can use today for running those stress tests. Like what we do in IBM for the team I work on is we have a dedicated performance team that will kind of just continually consume our drivers that we're producing, and they'll run, stress tests on their special machines that are, on bare metal and whatnot.
Yeah,
but not every team can do that.
No, but in your case, you would like to have realistic performance, and my case is less, like load tests and more like torture tests. We just would like to see whether the project breaks. So we are not sticking too long. So you're building a product, and we are in projects. So the projects in one point are almost over. So they are in maintenance phase, or they are just very little adjustments to the business logic. It's not like the cadence or the number of features remains the same. In one point of time is almost done. And so we would like to see whether the project will break, in which load it can actually sustain. This is the main reason we are doing this. And with Kubernetes or OpenShift environments, it is fairly easy. So usually we have a Jenkins pipeline, and the Jenkins comprises the master and slave. And you can say, okay, the slave is for stress tests, and you can request 2 CPUs or 4, whatever you need, and memory. And then you get a pod, and you can generate enough load to see whether your application break or not. And what I would like to see is, how the server handles 503s. Are there enough JDBC connections in the pool or JMS connections? And what about parallel behavior, and how much traffic one node can actually handle?
Yeah. Okay. Yeah, that's a good distinction to make. So I was talking more performance testing, and you're talking stress testing there.
Yeah.
So on the topic of stress testing, have you ever tried out, there's a library out there called ToxiProxy. I think it was hotels.com put out a interesting blog about it. But basically what it does is it, at the TCP layer of a system, it can simulate network latency, cut connections, things like that.
ToxiProxy? No, never, but this seems like an interesting project, so I'm writing it down, put it to show notes. And you are already pretty far. In my project, I'm really, I'm fighting for the GMH, and you said developers. The problem in projects is not that the developers or contractors, more like the people who hire the developers, because for unknown reasons they just would like to see high code coverage, and the code coverage comes just with unit tests, and so everyone writes JUnit tests like crazy. And they are pointless. So no kidding. So the developers writing unit tests for getters, setters. Recently, I saw unit tests for enums, and they enumerated all the values. Then constructors to see, whether the constructors are working properly, and this is completely pointless.
Yeah, I agree 100%. I think if you have management-directed code coverage numbers that developers have to hit, I think that's really a failure of management. Because in my opinion, code coverage is important to a certain extent. But if you're measuring it, using it as a metric that must be met is about as useless as measuring lines of code delivered by a developer or number of commits delivered by a developer. It can be so subjective, and trying to get to some arbitrary number is just, developers are smart. They're going to game the system in one way or another, and it's not going to result in a higher quality product.
Exactly. And at recent podcast with James Wilson, and he had interesting point that he made an interesting point and said that the code coverage was great at the very beginning of the extreme programming, because it was like gaming point, to move developers to write unit tests at all. So the code coverage was great, to see how many tests you wrote, but right now they are pointless, basically.
Yeah, and I think one thing it causes is I think having too many unit tests can be a problem, in the sense that you're testing the implementation of an application, not the behavior of it. So the only thing that your end user cares about is, does the application behave correctly? Mm-hmm. And they don't care how you implement that.
Yeah.
And go ahead.
This is perfect what you said, because this is exactly what happens. It's like if you consider a resource with injected facade. So a JAX resource, almost no implementation. And I saw unit tests where the reasons, let's say, 300 lines of code, and the unit test 5,000, because everything is mock out, the response and so forth, and they are measuring in the unit test, or they are verifying or asserting in unit tests how often the header method was, or headers object was invoked, which is absolute pointless, because if you change something in the production code, you will have to rewrite all the unit tests, which is really bad for productivity and maintenance hell.
Yep, that's exactly what I was going to say next, is that too many unit tests causes it actually becomes impossible, or it significantly increases the cost of refactoring an application. A developer should be able to refactor an application in whatever way makes the most sense to them, as long as they're not, altering the external behavior of that application. As long as the inputs and outputs remain unchanged, they can do whatever they want with the internals code. And if they have to, rewrite 100 unit tests every time they try to refactor a class, they're just going to stop refactoring and stop, cleaning up code smells and things like that.
Yeah, exactly. So, and back to your survey. So, I would say in let's say complex project, we will have several hundred unit tests, and they will run in seconds because everything is mock out, and they would run first. The next wave are integration tests with the entity manager, so persistence, and they could run slower because I don't like to use embedded databases. They behave usually differently to the real databases. So let's say we're using Postgres or Elastic or whatever in the cloud. So what we sometimes do, even we use port forward, to use a real data, not real production-like database in dev stage or int stage, integration stage, and have almost real behavior, which is a little bit slower. So the integration test can take minutes. And the system tests, it really depends on the system and what the system is doing, but they can be slower. But the cool story is with this sorting, the unit tests come first, and they are the most of the tests. Then the integration tests, the viewer tests, and the system tests come last. So if you are working, if the unit tests break, you don't have to wait because it's a dedicated stage in the Jenkins pipeline until the integration or system test kicks in. So it's fairly productive. So and how slow the whole thing is, it really depends on the app. This is really hard to tell. But for my current app, this is like a simple microservice. It's really simplistic, but the whole pipeline takes with deployment on Kubernetes, server startup, deployment, and all the tests and stress tests takes 40 seconds, like the smoke tests. So the whole pipeline takes around 5 minutes.
Okay, yeah, that's really good. And I think that makes total sense, putting your shorter tests first. One of the things I was attempting to get at with my survey, talking about test run times, is pairing those results with what gives you the most confidence. So one of the other questions is, what gives you more confidence, unit tests or integration level tests? And so far, the responses have been about 75% of developers say their integration tests give them more confidence than unit tests. So that really wasn't a very surprising response to get, but it kind of confirmed my theory. And it shows that integration tests are really do more for us in the sense of the true purpose why we're writing tests, which is developer confidence. And unit tests are mainly there as a quickly running, easy to write test. So one of the things I'm looking at is trying to kind of blur the lines between those two types of testing. So, what if we could have integration tests that are as easy to write as unit tests, or as run as quickly as unit tests? Then we could, I think, get some really interesting test suites out there.
Yeah,
and then developers won't have to choose between unit tests or integration tests or system tests.
Yeah, but it really depends on the application. So one project which I can open source, but I don't have actually time for it, but was a commercial project, but now I'm able to open source that. And what it was is it is a Java EE microservice which uses Google's, Firefox's, and Microsoft's the push notification gateways and sends messages which they appear as desktop notifications on PC or mobile phones. And there was quite a lot encryption involved. And I started with system tests, but it was really hard for me because I did lots of mistakes at the beginning with base 64 encoding and all that stuff. And only with unit tests, I was actually able to implement the application at all, because I just look at the specification and then wrote a small test for the encryption, and then build the application bottom up until I wrote the first system test. But this is an absolute exception from the rule. All other projects with Java EE, you get so much out of Java EE, so everything is simplistic, like object relational mapping. We get everything for free, so you can absolutely start with a system test.
Yep, for sure. Yeah, there's always exception cases. So that's why I always avoid saying always and never.
Yeah.
But yeah, I think it's good. One thing that I like to look at is the 80% rule. So if it works in 80% of cases, then it's probably a good, default opinion to have.
But what would be cool, actually, so I'm talking with you right now. So if, let's say, the application server will come with, let's say, code coverage mode or test mode. And then I could fetch the code coverage via an endpoint like metrics, right? So I could have let's say, endpoint called coverage. I could hit that after the tests, and I would get JSON-like structure which tells me, 80% were tested, and this packages and the code coverage for each package.
Yeah, that would be really cool, actually.
This is a unique feature. So if you like, we can stop recording, so you could start with hacking on that for Open Liberty.
Yeah, sure.
But this would be actually, because then, after the unit test, you could even automate this and see I'm actually testing in this package, and if the threshold is less than 50%, I'm just stop, and my pipeline will stop working. So this would be actually a nice feature. Yeah, definitely.
There's probably a patent in there somewhere.
Yeah, the library Jakarta, it works. The problem only is it writes a binary file like jakarta.exec, and it's only available after the server is stopped. And it would be nice to have a ASCII representation of the results there, so you could read the results without loading this into an IDE. But This would be a nice and open source project, actually.
Yeah, definitely. I think one of the I'm not sure how involved he is, but one of the former developers of WebSphere is actually, at least I've seen him proposing commits to the Jakarta library.
We have to ask him, so we have to schedule a podcast with him.
Yeah, for sure.
Perfect. So any other questions regarding testing?
No, I think we covered a good amount of material today.
So perfect. So thank you, and let's have a chat in a few weeks again about probably complete different topic, or even Jakarta as a service.
Yeah, sounds great. Thanks for having me.
So thank you. Bye.
Bye.